running tests that fail randomly, skip unexpectedly, or execute in the wrong order. You're not alone. I'm Guy Harith from Kivo Code, and in today's TestNG Deep Dive, you'll master the annotations that give you complete control over test execution. By the end of this video, you'll understand exactly why this test runs before this one, how to make tests depend on each other, and what happens when dependencies fail. Plus, I'll show you a live failure lab where we intentionally break things to see TestNG's dependency handling in action. If you watch my first TestNG tutorial, you learn the basics. Now we're going advanced. Let's dive in. But first, if this sounds useful, hit that subscribe button and the notification bell. I release new QE tutorials every week. In my first tutorial, we touched on test, but TestNG has many different annotations that control exactly when and how your tests run. Without proper annotations, you get this chaos. In this code, the first method is supposed to initialize the database, and the second test case should use that database. But look at the result. TestNG actually runs the useDatabase method first, and only after that, it runs the initialization. So in reality, the useDatabase test fails because the database was never initialized in time. Tests run in random order. Setup or teardown code fires at the wrong times, and debugging quickly becomes a nightmare. But when you apply the right annotation strategy, you unlock a beautiful, predictable flow where your environment is prepared before tests run. Each test executes in the correct sequence, and cleanup happens automatically at the end. In this video, I'll walk you through the complete annotation lifecycle step by step. We'll run live code, and you'll see the exact console output so you can clearly understand how the pieces fit together. All right, let's take a real-world scenario to understand why TestNG annotations matter. Imagine I'm automating a simple flow with 3 test cases. First test case, log into the application. Second test case, verify the profile details. And third test case, edit the profile information. Now, if I just write these 3 methods with only a test, you might think TestNG will run them in the order I wrote them. But that's not the case. By default, TestNG runs test methods in alphabetical order by their names, not by their position in the file. So here's what happens. If my methods are named edit profile, login, and verify profile details, TestNG will run edit profile first, then login, and finally verify profile details. Which makes no sense in real life, right? Because if you're not logged in, you can't possibly verify or edit a profile. For the record, focus on the results and its execution order here. Because I haven't added the real assertions, that's why this shows all test cases as passed. This is the first lesson. Plain test follows alphabetical order, which is fragile and can break your flow. Now, how do we fix this? One way is to use priority. By default, TestNG sorts by priority number. Lower runs first. So I can mark login with priority 0, profile verification with priority 1, and profile edit with priority 2. This way, the flow looks correct again. Cool, it worked. But there's still a hidden problem. Let's say the login test fails. If that happens, TestNG will still go ahead and try profile verification and then profile edit. And of course, in a real case, both of those will fail too, because the prerequisite action never worked. So at the end of the run, my report shows 3 red failures. But in reality, I only have 1 real defect in the login. The others are just noise. This is where dependsOnMethods comes in. I can tell profile verification to depend on login and profile edit to depend on both. Let's try it. Now if login fails, the others will automatically be skipped. My report is crystal clear. 1 failed, 2 skipped. That gives me an immediate signal that the root cause is the login, not 3 separate bugs. So far, we've learned how to use priority to order execution and dependsOnMethods to make results cleaner. But let's step back for a second. Think about this. One option is to make every single test independent. That means each test opens the browser, logs in, performs its steps, and then closes the browser. This works, but in a real automation project with hundreds of tests, that's extremely wasteful. We'd be opening and closing browsers hundreds of times, and that slows everything down. So how do we balance independence with efficiency? Let's change our example. Imagine I'm testing a website with 3 navigation buttons: Home, Shop, and Contact Us. I want 3 separate test cases that check each page. These tests don't depend on each other. But if I put the browser opening code inside the first test and the closing code inside the last test, then I can't run them individually. That's a bad practice because I lose flexibility. Instead, I want a way to open the browser one time for the whole class and close it one time at the end, no matter whether I run one test or all of them. And that's exactly where annotations like @BeforeClass and @AfterClass come into play. With @BeforeClass, the browser opens once before any test runs. With @AfterClass, it closes after all tests finish. That way, the Home, Shop, and Contact Us tests can run independently and still share setup and teardown efficiently. Let me quickly showcase it. See how it worked? Even if I run the entire class, it worked. Even if I run just one test case, that also worked. And this brings us to the bigger picture. TestNG gives us a full life cycle of annotations. You have @Before Suite and @After Suite, which wrap the entire test suite. You have @Before Test and @After Test, which work around blocks defined in your TestNG XML. Then you have @Before Class and @After Class for one-time setup per class. And finally @Before Method and @After Method, which run before and after each individual test. In this example, you can see the order it has run, starting with Before Suite all the way to After Suite. When you combine these correctly, your test suite becomes predictable, efficient, and easy to debug. You know exactly what runs before and after each test, and you can scale up your automation without getting lost in chaos. So remember the story. @test alone equals alphabetical order, not the order you wrote them. Priority fixes order. Depends on fixes misleading failures. Before and after annotations optimize setup and teardown. Once you master these, your tests stop being fragile experiments and become a reliable automation framework. And that's the real power of TestNG annotations. All right, quick recap. Today we took the chaos out of TestNG. You saw how priority sets intent, depends on methods expresses real prerequisites, and gives clean skips instead of cascaded reads, and @before/@after at the right level, suite, class, method, creates a predictable lifecycle. Do this and your suite becomes easier to debug, faster to run, and way less flaky. Next up in Annotations Deep Dive 2, we'll go hands-on with that data provider for clean data-driven tests. When to pick at parameters and assertions that tell the truth. Hard versus soft asserts, expected exceptions, and messages that point straight to the bug. If this helped, subscribe, hit the bell, and drop your biggest TestNG pain point in the comments. I'll include it in the next episode.